Hello everybody, so in today's video, we'll be going through 2024 AMC10B, problems 11 through 15. And in my opinion, number 15 is a very tough one. So, and if you enjoy this video, consider subscribing, leave a like, or just leave a comment. I'll answer your questions, and let's get on. Number 11, in the figure below, WXYZ is a rectangle with WX is 4 and WZ is 8. Point M lies on XY, point A lies on YZ, and angle YMA. WMA is a right angle. Areas of triangles WXM and WAZ are equal. What is area of WMA? So first we can set this as X, and so this is X over 2 because these two areas have to be equal. This is 4 minus X over 2, 8 minus X. We notice that these two are similar triangles because this angle is equal to this angle, and vice versa for these two. So we get 8 minus X over 4 is equal to 4 minus X over 2 over X. Cross multiplying and then adding, we can factor this, X minus 8, X minus 2. Obviously, X can't be 8 because then A would all the way be down here because X over 2 is 4. So obviously that can't happen. So X is equal to 2. If X is equal to 2, then we can simplify all of these equations. So this is 2, this is 6, this is 3, and this is 1. So the area of this is 4, area of this is 4, area of this is 9. And so the area of this is 32 minus 17, which is 15. Problem 12. A group of 100 students from different countries meet at a mathematics competition. Each student speaks the same number of languages, and for every pair of students A and B, student A speaks some language that student B does not speak, and student B speaks some language that student A does not speak. What is the least possible total number of languages spoken by all the students? Alright, so since there's only 5 answer choices, we can just try them all. Let's say there's 9 possible languages. There's 9 total languages spoken by the students. Let's say the languages are A, B, C, D, E, F, G, H, I, right? So, what this question is asking is, for example, A speaks A, B, and C. B speaks B, C, and D. And these still work because, well, there's one language that B doesn't understand, and there's one language that A doesn't understand. So, we can just choose, for example, in this case, we do 9 choose 3. And what is 9 choose 3? 9 times 8 times 7 over 3 times 2. It's 84, which is not 100. So we need to figure out a configuration that allows us to get more than 100 students. So if we do 9 choose 4, so each student gets 4 languages. And like I said, whatever configuration will work because they're different for language. So this is 9 choose 4, which is 9 times 8 times 7 times 6 over 4 times 3 times 2. This gives us 18 times 7. And well, this is more than 100. So A, 9 works. Moving on, problem 13. Positive integers x and y satisfy the equation square root x plus square root y is equal to square root 1183. What is the minimum possible value of x plus y? So we notice that 1183 is 169 multiplied by 7. So what this means is that square root x plus square root y is equal to 13 root 7. Which means that x is equal to a squared times 7, where a is a random integer. Y is equal to b squared times 7. And so a plus b is equal to 13. In order to minimize this, we can set a as 6 and b as 7. Multiplying it in, we get 36 times 7 is 252, and 49 times 7 is 343. Adding it up, 252, 343, we get 595, B. Moving on, problem 14. A dartboard is the region B in the coordinate plane consisting of points x, y, such that absolute value of x plus absolute value of y is less than or equal to 8. A target T is the region where x squared plus y squared minus 25 squared is less than 49, less than or equal to 49. A dart is thrown and lands at a random point in B. The probability that the dart lands in T can be expressed as m over n times pi, where m and n are relatively prime positive integers. What is m plus n? So first of all, we can take the square root. X squared plus y squared minus 25 is less than or equal to 7 or less than or equal to negative 7. And if it's less than or equal to negative 7, we have to flip the sign. So now we add 25 over. We get x squared plus y squared is less than or equal to 32, or and x squared plus y squared is greater than or equal to 18. And these are two equations where we have a circle These are equations where we have one circle with radius root 32 and the other one with radius 18, and we want to find this area. This is the target. This is pretty simple. We do 32 pi minus 18 pi to get 14 pi. And the total, well, what's the total? Let's handle that. This is the total area. So let's draw a graph. Well, absolute value is just this, where this is 8 root 2. So multiply that, it's 128. So 7 pi over 64. 7 plus 64 is 71. And you can also graph this on Desmos and see what it looks like for yourself. This is a little bit bad of a graph, but we're trying to make this fast. So number 15. A list of 9 real numbers consists of 1, 2.2, 3.2, 5.2, 6.2, and 7, as well as x, y, and z with x less than or equal to y less than or equal to z. The range of the list is 7, and the mean and the median are both positive integers. How many order triples x, y, z are possible? So the range is 7, and we can do casework on that. So case 1, z is 8. If z is 8, then we have 1 is less than or equal to x is less than or equal to y is less than or equal to 8. And this satisfies that the range is 8 minus 1 is equal to 7. Now, case 2. X is equal to 0. If x is equal to 0, then 0 is less than or equal to y is less than or equal to z is less than or equal to 7. So 7 minus 0 is 0, 7. And case 3, 0 is less than x less than 1. So that means that 7 is less than z is less than 8. And this is where c minus x is equal to 7. So you might be like, well, why can't z be 6? If z is 6, then 7 is like the greatest integer and is the greatest number, and z will not be counted in the range. Because keep in mind, the range is the highest value minus the lowest value. Same with if z is 9, then x would have to be 2, and 2 is no longer the smallest value. So these are our only 3 cases. So, and now keep in mind, one of x, y, and z have to be the median because the numbers are all not integers and 1 and 7 are too far apart. So pretty much x, y, one of x, so x, y, or z have to be the median because, well, 1 and 7 are way too far to be the median, and the median is a positive integer. Okay, moving on with case 1. So case 1. So in this case, z is 7. Case 1. So in this case, z is 8. So we now figure out the mean. So these all add up to 24.8. So we get 24.8 plus z, which is 8, plus x plus y over 9, and that's the mean. And this has to be a positive integer. So 32.8 plus x plus y is a positive integer. So x plus y is equal to 36 minus 32.8, or is equal to 45 minus 32.8. The issue with the top one is that x plus y is equal to 3.2, and obviously 3.2 is not big enough to be included in the median, because it has to be greater than 3.2 to be included as the median, and well, x has to be greater than or equal to 1 in this case. Okay, so now this one. So then x plus y is equal to 12.2, and we find out that we can do 6 comma 6.2. And well, 6 is the new median, and this works out. So 6 comma 6.2 comma 8 is one of our possible choices. Now, case 2. So case 2 goes as follows. We can do x is 0. So we have 24.8 plus y plus z over 9 is an integer. And y is less than or equal to z is less than or equal to 7. It's greater than or equal to x, greater than or equal to 0. So, like follows, y plus z can be equal to 27 minus 24.8. Or y plus z can be equal to 36 minus 24.8. And well, this is way too small to be even part of the median, because neither y or z can be the median. So this gives us 11.2. So how this can work is that y can be 4 or y can be. If y is 4, then z is 7.2, which obviously is not less than 7. If y is 5, then z is 6.2, which works. And obviously, if y is 6, then it won't be the median. And now we have our last case, case 3, which is 0 is less than x less than 1, and 7 is less than z is less than 8. So in this case, we just have to write it out. So x comma 1 comma 2.2 comma 3.2 comma y comma 5.2 comma 6.2 comma 7 comma z. So y has to be the median. So y has to equal 4 or y is equal 5. If y is equal to 4, then x plus z plus 28.8 is divisible by 9. So x plus z is equal to 7.2. And just because this x is equal to 0.1 and z is equal to 7.1, which works. If y is equal to 5, x plus z plus 29.8 divided by 9, x plus z is equal to 6.2, and this is clearly impossible because the gap between z and x has to be 7. So we have 1, 2, 3 possible values to get C as our final answer. Thank you for watching.